So today I'm going to be explaining the intermediate value theorem, and I'll show you how to use it with a few practice problems. So this is the definition of the intermediate value theorem, and it states that if f is continuous on the closed interval from a to b, and k is any number between f of a and f of b, then there is at least one number c in the interval from a to b such that f of c equals k. And this graph right here can be used to visualize the intermediate value theorem. So I drew 2 points and I just labeled them a f of a and b f of b. And if you were to connect these with a continuous function, you would have to cross k at some point. This is an imaginary line and you would have to cross it at some point, which is what the intermediate value theorem is stating. Here's a practice problem, and these types of problems are common on quizzes, tests, and homework. Use the intermediate value theorem to show that f of x has at least one zero on the interval from a to b, and f of x equals 2x cubed minus 5x squared minus 10x plus 5 on the interval from -1 to 2. And so you would find f of -1, which is 8, and f of 2, which is -19, and then remember to write this in this statement. It's really important. F is continuous on the domain from -1 to 2, or whatever domain the problem is asking. If you don't write this, you can lose points on your quizzes and tests because continuity is necessary for the intermediate value theorem to be used. And then for your answers, you would write a statement similar to this. Since f of 2 is less than 0, which is less than f of -1, then by IVT there must be at least one value of c such that f of c equals 0. And here's a graph of that last problem, and you can see that there is a root in the interval, which we just proved. And this is the same type of problem but a different function. So f of x equals x squared minus 4x plus 2 on the interval from 0 to 2. And so you would find f of 0 equals 2 and f of 2 equals -2. And again, write that statement, f is continuous on the domain from 0 to 2. And for your answer, since f of 2 is less than 0, which is less than f of 0, then by IVT there must be at least one value of c such that f of c equals 0. And again, I graphed it so you can see that there is a root in the interval, which we just proved. For this practice problem, it doesn't explicitly say use the intermediate value theorem, but this is another way to word the problem for you to use it. Prove that the equation has at least one real root in the given interval. And the equation is cosine of x equals x squared on the interval from 0 to 1. And you can rewrite this as x squared minus cosine x. And you would plug in 0 and 1, again, f of 0 equals -1. And then you could use your calculator to plug in for 1, and f of 1 is right here. And again, write this statement, f is continuous on the domain from 0 to 1. And then for your answer, since f of 0 is less than 0, which is less than f of 1, then by IVT there must be at least one value of c such that f of c equals 0, which is a root. And here's a graph, so there is a root in the interval. And this is a different type of practice problem. So let g be a continuous function on the closed interval from -4 to 3. A few values of g are given in this table right here, which interval must contain a solution to g of x equals 7. So for that question, you would need to find which interval has 7 between g of a and g of b. And for that, c is the answer because g of 1 equals 4, and g of 3 equals 8, and 7 is between 4 and 8. And it wouldn't work for the other ones because g of -4 is 1 and g of 0 is 2, and 7 is not between 1 and 2. and g of 0 is 2, g of 1 is 4, 7 is not between 2 and 4. And here's an example where the theorem can't be used. So f of x equals 2x minus 3 over x minus 1 on the interval from 0 to 2. And the theorem can't be used because f of x is not continuous on the domain, because the x minus 1 in the denominator would tell you that there's a vertical asymptote at x equals 1. So that means it wouldn't be continuous. And that's the intermediate value theorem.